Hello, my friends. I am doing a head map of a hard disk which is Seagate 500 GB laptop hard drive with the following parameters here. I have already done a complete checkup of the hard disk. Uh, I have done a diagnostic optimization and completed it. There are as seen from the beginning. This was connected to Spark. The project was loaded, and after loading the project we did a Nebula diagnostics. Drive showed all parameters okay except the head's health was H0 was 98% and H1 was 100%. So head 0 had only 2% loss of health. So then we built a head map successfully, and this is the result of the head map. We found that the hard disk had two heads, head 0 and head 1. We applied parameters to both the heads, and we will go into the settings and see where everything is saved. We would save everything on C drive. C drive, I have made a folder called Spark. So the parameter project folder is here, and we will also save all the parameters of imaging in the Spark folder. Okay, so now since the head map is built, since I have enabled both the heads, since head 0 is 98%, 2% less than normal, and head 1 is 100%, a normal head. Let's see how the parameters go ahead. Now I have adjusted the drive on skip badge, so it will skip badge or show us red sectors while skipping on head 0 and head 1. After some time I will be shifting on balanced and then on dig badge. Let's see the speed of the drive on head 0 and head 1, and whether a loss of 2% really affects speed or not. I have started a full image of the drive. It is saying there is not enough space, 21 GB space is available and needs a lot. I say continue. I don't want to show the whole project. Now you can see head 0 is imaging with the speed of 2.5 Mbps, 5 Mbps, 1.1 Mbps here, 949 kbps, 843 kbps. The average speed which is maintained is 800 to 900 kbps, with a lot of red sectors being thrown and unable to get data from the red sectors. Also you can see is corrupted data from non-reading sectors has amounted up to 23 MB. Okay, and the total amount of good data read is 38 MB. Now suddenly my hard disk has shifted to head 1 and was there for a very little time and again shifted back to head 0. So head 0, as we can see, that it is giving corrupted data with a speed of 572 kbps. Now what I shall do is, I definitely know that head 0 is not giving data. Maybe the health of the head is reduced by 2%. Let me shift it on balance on the fly. So I've shifted on balance on the fly to see whether I am getting any green blocks or not. So on head 0, still everything is absolutely red, no data there. This proves to me that a bad head, even by 1% or 2% less, may not give me data at all. The health is 98% of that head. So would I call this as platter degradation completely, or a bad head 0? Now you can see somewhere it has given me a green patch, but everything is again. I would like to know if it is platter degradation, because I will try to say dig bad with the same head. You can see dig bads is giving me data on head 0 with no bad sectors now, with the speed of 86 to 104 kpbs. Well, easily proves to me that the media is corrupted here. The head can give read retries, but the media is so corrupted that the head requires real effort to take out data, and the speed is 117 kpbs. Now, if the speed increases suddenly to mbps, that means that patch was a corrupted patch, so the platter surface there could be bad. Now you can see that there is no red patch at all, proving to me that heads were going bad because the media was bad and putting a lot of effort on the heads to read the data and give it in the hard disk. Okay, now I shall on the fly put it back to balance. Let's see what happens. You can see the speed is 1.6 mbps and the reds have started again. There are some greens, many reds. So let us again switch it back to dig bads. It is still on head 0. Again it started giving me data from dig bads with a speed of 110 kpps. Now let me see what happens on head 1 if it shifts to head 1 in some time. If head 1 gives me a top speed of about 10 to 20 mbps, I would rather believe that the surface of head 0 or the platter on which is reading by head 0 is degraded. So let's hope that head 0 switches to head 1, or we will do some more thing, that we will on the fly go on skip bats, because skip bats will shift a lot of data at one time, and as soon as it will come on head 1, maybe we will get full speed of the drive. So you are seeing now see it has come on head 1, the speed has gone up to 51 mbps. Again switched back to head 0. Head 1 has been allotted a very little amount of data zone, and head 0 has now again it has got on head 1, you can see the drive suddenly switches to a speed of 57 Mbps. It's so simple that head 0 is quite weak and head 1 is normal. Now again you are saying that the speed is reduced to 577 kpbs on skip batch. On head 1 again 10 mbps speed now, 31 mbps speed was maximum, and head 0. So now let us do a little more testing. What we will do, we will bring it back to front and we will say cancel imaging. I am saying yes, I want to cancel the process. Now what I will go here, I will say on head map tool, disable head 0. That is all I have to do. Apply, and I will tell Spark to start full image. So you can see now I have disabled head 0. Data is coming out from head 1 only. You can see that the speed is from 19 Mbps to 41 Mbps. Average speed being maintained at 30-31 Mbps. At times a speed of 60 Mbps is also received. So this is a direct proof that the platter of head 0 is corrupted, and data to be obtained from a hard disk depends a lot upon the platter integrity and the health of the heads in percentage. It's not that a 98% health will not read data, but the speed will remarkably reduce, and it will give data at the speed of kpbs 200-250 kpbs on dig batch only. Now we do something more. Now you can see that the speed is 40 Mbps and it has covered a lot of distance, enough distance to tell me the file and folders of a hard disk if this hard disk was not encrypted. Now I shall cancel this process. I shall say interrupt, yes, and what I will do is I will go on head map tool. I will disable head 1 and tell head 0 to enable itself and click on apply. Okay, now head 1 is disabled. I say give data from dig batch. That means whatever data here which was corrupted 7.3 MB, please read it back. Whatever was bad on head 0, give me that data. So now let's see whether it does that or not. So you will see that the corrupted data which we were not being able to obtain is now being obtained. This is retrieval of data from bad sectors on dig batch. So this is again a direct proof that at 98% health also, but with the reduced speed in kpbs, we can get complete data, but it may take an enormous time to finish off reading. Now you can see that what all was corrupted is becoming lesser and lesser, and finally you can see that there is no corrupted data on head 0. It is moving forward and giving data, taking out data from all the bad sectors which are coming in its way, and we can see this process happening on head 0, which is really bad. All the red sectors are giving data. There is no corruption of sectors left behind. Now the dig bad process is really helpful in giving us any kind of bad sectors. If they are really physically bad, you will not get data. But if they are logically bad, dig bad extracts data from these bad sectors. This phenomena is very difficult to achieve on PC3000 and MRT. This phenomena is obtainable on Rapid Spark, Spark and Deep Spark. You can try this phenomena on PC3000 by adjusting the parameters. I really doubt that you can get a complete data from that hard disk, and even if you get it, the process would be the same, but rather your adjustments would be different, and you would definitely put skips on such sectors and your files may not work. So Spark is superior as a imager, as a disk explorer in giving you data. So now what has happened, that we have almost covered a lot of data on head 0 and head 1. So I hope readers you have understood that dig bads definitely gives us data from bad sectors. It's a right obvious practical example in front of you. That is why I always emphasize buy a tool which can give you working data, which can give you more practical working data than what you get from other devices. So thank you friends for watching this video. I hope you have liked it. My main purpose to show you this video was that on dig bads, Spark really digs bad sectors and gives you data. As a trial proof for the last few words, I shall skip on balance. I shall skip on balance and let me see what happens. On balance, you can see corrupted data has started again. The speed is 103 kbps. Only a few patches are recoverable. And skip bads will still be worse, will not give any data. And as a token of solid proof, let me shift it to dig bads. I shift it on dig bads. Let's see whether good data is coming or not. Yes, good data has already started coming. So my viewers, this is a direct proof that dig bads in Spark and Rapid Spark definitely digs data from bad sectors and sees to it that all the blocks are green, and if they are red, you can still give a third try on them once your imaging completes. Thank you my friends for watching this video. Have a nice